Alright, here is a problem from the sample exam from this course. So, this is like the group theory question that's really easy if you know how group theory works. But even this wasn't so easy. So let G be a finite group of order 224, prove that G cannot be simple. So let G be a group of order 224, which if you work it out is just 2 to the 5th times 7th. And assume for contradiction G is simple. We know that the number of 2 CELO subgroups is congruent to 1 mod 2 and it divides 7. That's by the CELO theorems. This implies that N2 is either going to be 1 or 7. Now if it were 1, then by the typical argument that we do for these types of problems, the set of CELO 2 subgroups is invariant under conjugation and G acts transitively on this set. And so, because there's only one CELO 2 subgroup, it means that for every element of G, G times that subgroup times G inverse will be that subgroup, which means that conjugating this subgroup by any element of G fixes it. And so that means that this is a normal subgroup, and it's a non-trivial group, so it's a non-trivial subgroup, so therefore it's a non-trivial normal subgroup, and therefore G is not simple, which contradicts our assumption that G is simple. So therefore, N must be 7. Now, G acts non-trivially, transitively actually, on the set of CELO 2 subgroups. Now, by basic group theory, and it's not basic group theory. It's a separate argument that you typically need to make, but we've seen it so many times that I think we can just automatically apply it. So what it says that is if you have a group acting on a set non-trivially, then the order of the group must divide the factorial of this order of the set. And so G must divide this number factorial, which is 7 factorial, which, I mean, is 50/40 if you work it out, but you actually have to do, like, math here. You have to, like, actually write out the numbers. And that's not a thing that happens on a lot of these pure math exams. And it's especially not something that I like to see. And then you have to prove that 224 does not divide 50/40 evenly, and that's to prove that you have to actually do long division. Like what is this? I don't know. But therefore, you arrive at so 224 does not divide 50/40, but this here says that 224 divides 50/40, and so we have a contradiction. So regardless of whether N2 is 1 or N2 is 7, we get contradictions. Therefore, it can't be the case that G is simple. So G cannot be simple, and that's all there is to this problem.